Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to look at the trapezoidal rule for doing numerical integration. So in the past couple of videos we've talked about definite integrals and we've learned how to find definite integrals. We've also talked about how we can use definite integrals to calculate area under a curve. In this video, we're going to look at definite integrals that are difficult or impossible to calculate, and we're going to take a look at how we can approximate that definite integral using a numerical method called trapezoidal rule. If we take a look at this example, with the integration rules we've taken so far, we're unable to do this integral. If we were to write this as x minus 1 to the power of negative 1, remember, our power rule will not work when our exponent is negative 1. So, if we wanted to find this integral, what we're going to do is approximate the area under this curve from 2 to 4. And when we find that approximate area, that's going to be the approximate integral. So what I'm basically going to do is approximate that area using trapezoids, and then that will be the same as the definite integral. Let's take a look at how we use trapezoids to approximate that area. If we were to take a random curve, f of x, and if we were to drop down perpendicular lines from that curve to the x-axis, and then if I were to draw a straight line from the y value of one point to the y value of the next point, I will have formed a trapezoid. And I can split this into n trapezoids, where n can be any number. So I'm going to label this x value x0, this will be x1, x2, x3, and so on, up until the last x value will be x sub n. Therefore, this will be xn minus 1, and this will be xn minus 2. And I can find the area of each individual trapezoid and add them all together. So I'm going to have n trapezoids. If we were to take a look at the first trapezoid, the formula for the area of a trapezoid is the average of the two parallel sides. So this parallel side will be, if this is x sub 0, this length here will be y sub 0. And if this x point is x1, then this length here will be y1. And this perpendicular distance between the two parallel lines will be the change in x from this point to this point. The area of a trapezoid is delta x times the average of the two parallel sides. So the average of the two is found by adding them and dividing by 2. So that would be the area of the first trapezoid. I could do the same thing for each of these trapezoids, and I'm going to put it all together and find the sum of all of those individual trapezoids. So the area of the trapezoids will be equal to, the area of the first trapezoid is delta x times y0 plus y1 over 2, plus the next trapezoid will be delta x times the average of those two. I could do the same thing with the next trapezoid. So its two sides would be y2 and y3, and so on. Up until the last two trapezoids, if this x value is xn minus 2, then the y value is yn minus 2. So delta x times yn minus 2 plus this y value will be yn minus 1. And then the very last trapezoid will be yn minus 1 plus this will be yn. This looks very confusing, and trust me, using this rule is much easier. I'm just showing you where the rule came from. We could factor out a delta x, and then I'm left with y sub 0 over 2 plus y sub 1 over 2 plus y sub 1 over 2, and so on, what you'll find is all these interior sides are sides of two separate trapezoids. The only ones that aren't are y sub 0 and y sub n. So y sub 1 over 2 plus y sub 1 over 2, it will end up being just y sub 1. So when I combine all this, I will get y sub 0 over 2 plus, when I add those together, I just get one of them, and so on with all of them. I continue on until yn minus 1, and then yn is divided by 2 because I only use that side in one. This is the formula for the area of the trapezoids. That's what we use as the approximation for the definite integral. If you didn't understand this, or you don't need to understand this, then let's just get to using it. So we've learned how to find the sum of the area of the trapezoids, and we know that we can approximate the area under a curve by taking the sum of those trapezoids. Therefore, we can approximate the definite integral by taking the sum of those trapezoids. In other words, the integral from a to b of f of x dx is approximately equal to delta x times y sub 0 divided by 2, and then all your interior y values, plus y sub n divided by 2. So just the first y value and the last y value are divided by 2, all the others are not. And we calculate delta x by subtracting b minus a and dividing by the number of divisions. So in your questions, you will be told the number of divisions, and the greater the number of divisions, the more accurate your approximation. Let's take a look at how we actually use this. It's not as complicated as it might seem. So we're going to do this question, the integral of 1 over x minus 1 dx from 2 till 4. And the question will tell us how many trapezoids to use. In this case, we're asked to use 4. Here's my formula. In order to use that formula, I need to calculate delta x, and I need to calculate these y values. So I'm going to start off with delta x, and it will be b minus a divided by n. So in my example, it will be 4 minus 2 divided by n, 4. So it will be 1/2. Then I start with my first x value, which will be x sub 0, and it should be a. It should be your first x value there. To have 4 equal increments, each of 1/2, I add 1/2 4 times to get the next x values. So x1 will be 5/2, x2 will be 3, x3 will be 7/2, and x4 will be 4. So I've gone from 2 till 4, and this should be your lower limit, this should be your upper limit. And I have equal increments of 1/2 from one x value to the next x value. Notice I have 5 x values when I have 4 trapezoids, and you should always have one more x value than the number of trapezoids. Then we find the corresponding y values by putting these x values into our function. Here's our f of x. So 1 over 2 minus 1 will be 1. y1 will be 1 over 5/2 minus 1, 1 over 3/2, which is 2/3. y2 will be 1 over 3 minus 1, which is 1/2. y3 will be 1 over 7/2 minus 1, which is 1 over 5/2, which is 2/5. And y4 will equal 1 over 4 minus 1, which is 1/3. Those are my y values. There's my delta x. Now I can plug into my formula. So the integral should approximately be equal to delta x, which is 1/2, times my first y value and my last y value get divided by 2. So 1 over 2, and all the other values are as is. So 2/3, 1/2, 2/5, and then the last one gets divided by 2. So 1/3 divided by 2. When we do the calculation, we get this definite integral equal approximately 1.117. Had we done more trapezoids, we would have had a better approximation, a more exact approximation. That's how the trapezoidal rule works. Anytime you're doing a numerical method, you're going to have lots of number crunching, but luckily we have calculators to do that for us. There's another numerical method that's used to approximate definite integrals, and it's called Simpson's rule. So I'm going to cover that in the next video, but try some of these on your own first. Take care, and we'll see you then.